The problem in countdown to display starter is to design a function that consumes the countdown type we defined earlier and produces a little image of the current state of the countdown. It might be something that would display on your phone if you were watching the New Year's Eve countdown. So again, the first step of the recipe is signature purpose stub. We can do that quickly. We're going to consume a countdown, and we're going to produce an image. And it's going to produce a nice image of current state of countdown. The stub is where we want to call the function countdown to image of a countdown. And the stub for functions that produce an image, I think it's kind of nice to make the stub just produce a blank image. And the way I make a blank image is I make a square of size 0. And it can be any color you want since it's of size 0, but I make it like that. So that's our stub. Let's run it. Where this function is not defined, this square right here. Oh, this is the bug about not saying require to HTTP image. If we go to the top of the file, sure enough, there's no require there. So we'll say require to HTTP/image. We'll run that. Okay, now we're okay. So this is a good example of why we check the well-formedness of stubs, and in general, why we want to run our code as often as you can. The sooner you find a little mistake, the easier it is to fix. It's easier to find one mistake now and another mistake in a minute and another mistake in a minute than it is to find all 3 of them in 3 minutes. So run your code as often as you can is the general rule we're going to want to use. Okay, so now we need to do examples. The question is, how many examples do we need and what should they be? So again, you can get some guidance for this by going to the How to Design Data page, going down to the section on itemizations, because this is an itemization, and the guidance here that says that there should be at least as many tests as there are cases in the itemization, and if there are intervals in the itemization, then there should be tests at all points of variance in the interval. Let's go back to the code and I'll show you what that means. Well, we know there's at least 3 tests. Okay? So let's quickly do that. Check, expect, count down to image of some value. I'll just make 3 of these. We know there's at least 3. And let's see, the first one corresponds to this first case of the type comment, false, so that's false. So now let's see. What should countdown to image produce when the countdown isn't running? Because remember, the interpretation tells me that this means the countdown has not yet started. So if the countdown hasn't yet started, I don't know, there's lots of things we could produce. Let's just produce that blank image again. You could produce something fancier than this. The goal here is not to make the best possible version of this function, but to understand what the design of this function is about. So that'll be the first case. And now we need a case for this interval. Now we're supposed to test every point of variance in the interval. Conceivably, we could test with 1 somewhere in the middle, like 5 and 10. But in this particular function, the behavior doesn't meaningfully vary across the interval. Sure, we're going to display 1 at 1 and 10 at 10 and 3 at 3, but we're always going to display the number. So it's going to really be enough to have a single test for this interval, maybe at 5. Now the question is, what do we want to display? Well, let's see. We need an image. And there's a function called text, which can turn a string into an image. And there's a function called number to string that can turn a number into a string. So if we made a text of some size, now right now I'm just going to put the size of the text here. We'll see next week that the right thing to do is define a constant for this, but I'm just going to put the size right there. So what this is saying is it's saying if we count down to image of 5, we should produce the text of the number 5 in font size 24 that's black. And what are we going to do if the countdown is complete? Complete is the third case. Well, I say for that, we'll just say text of Happy New Year. And that'll also be 24, but maybe it'll be some brighter color like red. Now, a very important thing has happened here, which is I've really worked out the behavior of this function using the concrete examples. So before I'm writing the actual code of the function, we did a lot of the designing of the behavior of this function. So that's the examples. Let's run them. Great, they all run, but some are failing. That means they're well formed. So now this was the stub. Let's comment it out. Let's put a note that says we use template from countdown. Let's get that template. We'll copy it down here. And let's see, we rename it. We rename it countdown to image. So in the false case, well, this corresponds to this example. So that's just that blank image again. And this case is, let's see, we're going to convert C, whatever it is. This will just be text of, here's number to string of C, size 24 and black. And when cons get complicated like this, we tend to put the question and answer on separate lines. That makes the cond easier to read. And then in this final case, that corresponds to this example, which is just text, Happy New Year 24, red. Let's see what's happening here. Let's try it. Number to string. This function is not yet defined. I didn't get the error here, though. Oh, right, the Dr. Racket version of this function is named with an arrow, like this. Okay, one of the tests didn't pass. Happy New Year differs from happy... Oh, I didn't put the exclamation marks in. Now let's try it. I'll save it and run it, and all 3 tests pass. Notice I had to fix 2 bugs there. In each case, what I did was I read the warning message, or I read the failing test. I looked at the highlighted code, and I used that to give me an idea of what the problem was and how to fix it. The key thing about having bugs in the code is just to expect that that's part of it. Don't get upset about it. Don't worry about it. It happens all the time. It's just part of it. The very best programmers in the world have bugs in their code. Fixing it is part of designing good programs. And we're going to talk more as we go through the course about techniques for finding the bug as our programs get more and more sophisticated. Now again, notice that the data definition told us there were 3 cases. It's an itemization that includes an interval. That gave us the template. It also gave us the examples, and it helped us fill in the template for the function. A lot starts with the data definition. Let me show you one little side point here. We saw that Dr. Racket names its number to string function number arrow string. And we named our countdown to image function countdown to image. That's because this naming convention here is something you're not going to get away with in other programming languages. So I wanted you to see this naming convention too. But if you wanted to rename this function, let me show you a neat trick. What you're going to do is you're going to click on check syntax here. And now when I hover over countdown to image here, it shows me all the calls to it. Or when I hover over one of these, it shows me the definition that defines it. Now what I'm going to do is on the Mac, I'm going to control click. On Windows, I'd right click. And I go to rename countdown to image. And I'll rename it up here using the other naming convention. And notice how it fixed all of them. But notice how it didn't fix the one that was in this comment. It only fixes the ones that aren't commented out. So now if you want to, you've got the function named the other way. This renaming command that I used is a thing called a refactoring. And it's very useful when programs start to get big to have tools like that for doing things like renamings. We'll talk more about that as we go on in the course.